Hey guys, and in continuation with the previous session, I am going to carry out some extensions in this elastic constant. So, as we already discussed, we having different kind of elastic constants to understand the material's behavior. So, according to the material deformation, this elastic constants which has been calculated. So as the elastic constant, the first one we know that is a modulus of elasticity. We used to call that Young's modulus, and second one we know that modulus of rigidity. We used to call it is a shear modulus. Third one it is a bulk modulus, and fourth one it is the Poisson's ratio. So we need to know the relation between the elastic constants. For example, if I am going to say about the elastic constants between Young's modulus and the bulk modulus is E is equal to, we know that 3 into K into 1 minus of 2 by M. So in short form, that Poisson's ratio, which can also expressed as 1 by M, and it can be represented by the symbol is mu. Okay. So here we know that E is equal to 3K into 1 minus of 2 by M. That is the relation between Young's modulus and the bulk modulus. If I am going to take a calculation about the relation between Young's modulus and shear modulus, we need to use this equation that Young's modulus is equal to 2 times of shear modulus into 1 plus of Poisson's ratio. Okay. So when a body is subjected to three mutually perpendicular like and direct stresses of equal magnitude, the ratio of the direct stress to the corresponding volumetric strain is constant. Okay. So if a body is subjected to three mutually perpendicular like and direct stresses of the equal magnitude, the ratio of direct stress to the corresponding volumetric strain is constant. So this is possible when a body is subjected to three mutually perpendicular like and direct stresses. Okay. So this volumetric strain is constant for a given material within the elastic limit. The constant is called, it is bulk modulus. So it is denoted by the symbol is, this is what you call that K. Okay, so that K is equal to stress divided by volumetric strain. So this is what you call that bulk modulus. If you find about the modulus of rigidity, here when a material is subjected to the shear within the elastic limit, the shear stress is directly proportional to the shear strain. So what do you mean by modulus of rigidity? Means it is the material is subjected to the shear, and the shear force, or it is within the elastic limit, the shear stress is directly proportional to the shear strain. So this is constant. It is, what do you call that, shear modulus. That shear modulus is also called it as a modulus of rigidity. So it is denoted by the symbol is G, or sometimes it can be denoted by symbol is C, or otherwise N. Okay. So this shear modulus is equal to shear stress divided by shear strain. It can be expressed as tau divided by phi. Tau represents it is the shear stress, where phi represents it is the shear strain. So the value of the shear modulus can be calculated if we know the value of shear stress and the shear strain. Okay. So based upon this, we going to find out one of the problem which has been stated, like the Young's modulus is given and shear modulus is given. They ask you to determine what is bulk modulus. So we know the relation Young's modulus is equal to 2 into shear modulus 1 plus mu, and by using this equation substitute the value of Young's modulus along with the shear modulus. Accordingly we can find out what is Poisson's ratio. If we find out the Poisson's ratio, we know the relation of bulk modulus and the Young's modulus, and we need to substitute this value. Okay, so this is what you call the 3 into k and 1 minus 1 by 2m. By substituting this value, you may find out what is the bulk modulus. Thank you.